Hello, everybody. So today we're going to start our graphing part of this unit by first looking at rates of change and slopes. Here's our two learning objectives for the day. I can calculate slope from a graph, and I can calculate slope given 2 points. Let's define what slope is. Now, slope is just the steepness of a line. Two different ways we could find it, which is our two different learning objectives, but from a graph, we could count the rise over run, find the slope. From two given points, we have this formula here. y2 minus y1 all divided by x2 minus x1. We'll go into more detail with that formula later on. But for now, let's talk about slope. Oh, just kidding. One more vocab word. We have rate of change. Rate of change is the rate of how one quantity changes in relation to another quantity. Most of the time, rate of change is mentioned when it's given in a graph. It's basically the same thing as slope. How are the y's changing compared to the x's? How's my output changing compared to the input? Now let's talk about slope. When I talk about slope, I like to compare it to roller coasters. Look at these 5 different roller coasters. How steep is the steepest roller coaster? Have you been on any of these roller coasters? Maybe that's Superman from Six Flags, maybe Accelerator from Knott's. I don't know if anyone's been to Ohio, but there's 2 of the biggest ones from Ohio, Magnum, Cedar Point, Son of Beast, Kings Island. There's Ghost Rider from Knott's Berry Farm. I don't like Ghost Rider. I'm not a huge fan of Ghost Rider. It's very painful to me. 2 of these roller coasters are completely vertical. Doesn't get any steeper than complete vertical. So those 2 would be the steepest. Now, when we're thinking of slope as far as our mathematical equations and graphs goes, I want you to think of these roller coasters going from left to right. Left to right. There's 4 different types. You could be going uphill, which is a positive slope. You could be going downhill, which is a negative slope. And then there's 2 special cases. The one I like to call zero fun roller coaster, and then the impossibly scary roller coaster, like those complete vertical ones we saw before. What kind of slopes do they have? Well, since it's zero fun, it's just completely horizontal, it's boring, that has a slope of 0. Completely vertical, huge, scary crash right there. It's undefined. We are so scared on this type of roller coaster, we can't even define it. It's an undefined slope. Keep that in mind. See if you could answer what type of slopes the following graphs have. Remember, there's only the 4: positive, negative, 0, and undefined. What does this slope have? Negative slope. What does this slope have? Positive slope. What does this slope have? Boring. That boring one, that zero fun slope. And what about this one? Undefined. So how do we calculate that slope of the line? Well, that's what we saw in our vocab from earlier. We were talking that rise over run. Now, to find rise over run, there's 3 steps. Step number 1, pick 2 points on the line. Step number 2, calculate that rise over run. Step number 3, determine the sign. Are we positive or negative? Are we uphill or downhill? So watch me do this one right here. We have this graph with this line. We're going to go through the steps we just mentioned. Start with picking 2 points. Now, when you're picking points, I want you to be very specific and pick points that are on the grid line intersections, on your graphing intersections. So, for example, you could pick this one, you could pick this one, you could pick this one, and you could pick one more. We like picking these ones because they're whole numbers. We don't end up with fractions or decimals. These are much easier to work with. Don't pick this one. Don't pick that one. Don't pick this one, because those are not on grid line intersections. So using some of those points, we're just going to count how much we rise up, how much we run over. Now, slope, you're going to see this, especially a lot in this unit, you're going to see slope shortened to just one variable we designate called m. I like to think of it as m for movement. So our slope is our movement. It stands for m. And slope is that vertical change divided by horizontal change, which is just that rise over run. So our m equals rise over run. So now the last thing, what sign is it? We'll look to see if it's increasing, going uphill, or if it's decreasing, going downhill. So let's see, going back to that problem, picking those points. Choose two of them that are on those grid lines we mentioned before. So I'm going to pick these two kind of right in the middle of the graph. Next, I want to count how much I rise up and how much I run over. So I rose up 2 points and then I ran over 1 point. So I could put that into my formula. Rise divided by run, 2 divided by 1. What's 2 divided by 1? Just 2. Now look for the sign of this slope. What direction is our graph going? Are we going uphill? Are we positive? Or are we going downhill? Negative. We're going uphill. Which means we have positive slope. So the answer to this example, our slope, our m, our movement, is positive 2. Do this one again. Step number 1, pick 2 points. I like picking the ones closer to the middle, so I'm picking these two right here. Remember, on the grid line, so that way they're clean points. Step number 2, calculate rise over run. I only went up 1 value, and then I ran over 3 values. Plug that into my formula, rise over run. My rise was a 1. My run was a 3. So I have 1/3 right now. What's the sign of this graph? What's the sign of this slope? Going downhill. That means I have negative slope. So my slope for this example, negative 1/3. Now let's find some using the slope formula. We're almost done. Now find some using the slope formula. They're not always going to give you the graph and have you find the slope. Sometimes they're just going to give you 2 points on that graph, and then you need to find the slope from there. This is the example of that happening. They gave you 2 points, 5, -3, -4, +2. They want you to find that slope. That's going right back to our, That's going right back to our formula that we had from earlier in the vocab. y2 minus y1 over x2 minus x1. The y2, y1, x2, x1, those are points given to us with the 2 ordered pairs. Remember, our ordered pairs are x, comma, y. So this first ordered pair is my x1, comma, y1, because it's my first x and my first y. Second point, x2, comma, y2. And now I'm just going to take those values and plug them into my equation, my formula. So I plug a 2 in for y2. I plug a -3 in for y1. I plug a -4 in for x2. I plug a 5 in for x1. And then I simplify. Add and subtract the top, add and subtract the bottom, then divide at the end. So what's 2 minus -3? Well, the double negatives there make it positive. That becomes 2 plus 3, which makes 5. -4 minus 5 on the bottom, they're both negative. So I add them together, keep it negative. That makes it -9 on the bottom. Can I reduce 5 over -9? No. So my slope is 5 over -9. Let's do it again. Our last example, we're looking at example number 4 here. We have 2 ordered pairs again. We're talking 0, -2, and 4, -2. Again, looking for our x1, y1, x2, y2, and then plugging it into our formula. y2 is my -2. y1 is my -2. x2 is my 4. x1 is my 0. So now I have -2 minus -2. Again, double negative. Makes it positive. That's -2 plus 2, which is 0. On the bottom, 4 minus 0 is just 4. So I have 0 divided by 4, which reduces to 0. So my slope in this example was nothing. Now let's talk up some rate of change. Rate of change, remember, is looking for the slope, just given it in the form of a table. So here we have a bunch of x's, 2, 4, 7, 8, 10, and a bunch of y's, 5, 11, 20, 23, 29. We want to find the slope. We want to find the rate of change from this set of values. Well, what you can do is just notice how much are the x's changing from each other, how much are the y's changing from each other. On top, 2 to 4 was plus 2, 4 to 7 was plus 3, 7 to 8 was plus 1, 8 to 10 was plus 2. On the bottom, 5 to 11 plus 6, 11 to 20 plus 9, 20 to 23 plus 3, 23 to 29 plus 6. Remember slope, rate of change. It's all about the changes in your y value and your vertical versus the changes in your x values, the horizontal. So we're going to take all of those green values, all the y differences, put them on top, and put all the x values, those blue values, on the bottom, and see if these ratios are the same. So I'll have 6 over 2 for the first one, 9 over 3 for the second one, 3 over 1 for the third one, 6 over 2 again for that fourth one. They all equal the same thing. They all equal 3. So this proves that my rate of change is 3. So again, looking at the differences, x's and y's, then divide them. There's your rate of change. Let's see it one last time. One last example. We have 0, 1, 2, 3, 4 for my x's, 0, 3, 6, 9, 12 for my y's. Looking at the differences between x's, well, I'm just adding 1 every single time. Looking at the differences for my y's, I'm adding 3 every single time. I could find those ratios the same way I did in that last example by just dividing y's over x's. So I get 3 over 1, 3 over 1, 3 over 1, 3 over 1. So I get the same rate of change as before. I get 3 again. In this lesson, we talked about slope being the steepness of the line. We found it in a graph. We found it with points. We also talked about rate of change, and we found rate of change given different tables. So a lot going on in this lesson. Email me if you have any questions about it. Thanks so much, guys.